this video, we are talking about MicroC OS 2 or Microcontroller Operating System version 2. Okay, MUCOS is a real-time operating system which was first published in 1992 by Jean J. Labros. It is completely written in C language. It is also a freeware. That means we don't have to pay anything for MicroC OS. Its version 2 is known as MicroC OS 2 and it has been in use in several types of embedded systems. Okay, how does it get its name? MicroC OS 2 is also known as MUCOS 2 and it is the acronym for Microcontroller Operating Systems version 2. The first letter from each word is taken, MCOS and version 2. And talking about the features of this real-time operating system, it is completely written in ANSI C and it is based on priority based real-time multitasking operating system kernel, and its code size is very small. It has 10,000 plus lines of codes and it is used in several applications like ATMs, camera, medical instruments, network adapters, etc. Okay, it is as I said earlier, it is a very small real-time kernel. Its memory footprint is about only 20 KB, so it can be used in embedded systems. It is a highly portable OS. So the features of MicroC OS 2 are portable, roamable, scalable, preemptive, deterministic, etc. So what do you mean by a portable OS? So as I said earlier, MicroC OS 2 is written in ANSI C. That means it is written in our C language and it provides portability to various number of microprocessors like 8086, so that we can write a program in the C language and easily port it to our target microprocessor like 8086 and all. Okay, then it is roamable. Roamable means, since we have seen that its memory footprint is only 20 KB, and if we have sufficient software, then we can include this OS inside the ROM of our product. Then it is scalable. So the MicroC OS 2 has 10,000 plus lines of codes and it consists of several functions, and we can select the required functions according to our applications so that the size of the kernel can be reduced to a minimum. Another one specific feature of MicroC OS 2 is that, as I said earlier, that it is a multitasking OS. It can manage up to 64 tasks, and out of which only 56 tasks are available to the user. It supports all the type of processors from 8-bit to 64-bit. Now, coming into the details of MicroC OS 2, let us see how the function names are written in MicroC OS 2. Okay, all the functions defined in this MUCOS 2 will start with the letters OS, which indicates that they are related to this operating system. Then, for example, consider this OS mbox create. Okay, this function means that it is related to the operating system. Mbox means mailbox services and create means creating a service. So in summary, we can say that this functions mean that this function is a part of operating system and it is related to the mailbox, and a mailbox is created. Similarly, OS create means that it is related to the operating system, then it is related to semaphore, and the function is to create that semaphore. So it is in this way all of the functions in our micro C OS are written. So a programmer can easily understand what it is by simply looking at the name of these operating these functions. Now, what are the different types of source files available in micro C OS2? So in C language we know that we save the file names with two types of extensions. One is .c and other is .h. .h means the header files. The header file includes all the predefined functions in the C library. For example, when considering the C language, we have iostream.h or stdio.h, which includes the standard input output files and the details of data types like int, float, etc. And all these specific functions like conio.h, like clear screen, gets, cout, cin, these all will be stored in our header files. Similarly, the creator of MUCOS2 also have created a master include file which is named as includes.h, and this can be found in every C files that is written in micro C OS2. So all the C files, almost all the C files will start with this sentence, which is hash include includes.h. This includes.h is the master include file, and it will contain the details of all the header files necessary for the working of our applications. For example, this is one of the includes.h file. We can see that it contains almost all the header files that are available in basic C language: stdio.h, string.h, stdlibrary.h, conio.h, like that, plus some of the files related to the operating systems, related to our MUCOS operating system, that is OS CPU.h, OS configuration.h, pc.h, mucos2.h. So this is the basic structure of includes.h, which is the master file of micro C OS2. Okay, then coming to our source files, there are two types of source files are available in micro C OS2. One is the processor dependent source file, and second one is processor independent source files. So processor dependent source files means, as I said earlier, this RTOS is used for embedded systems, and embedded systems consist of processors, and this MUCOS operating system can be ported to various types of processor. So in order to port our program to various type of processor, we need the details of the processor. For example, if we are using 8086 processor, then we need to know about the registers which are there in 8086. We need to know how many bits are these registers. We need to know what is the size of the stack of these registers. So all the details regarding the processor will be entered inside the processor dependent source files like os cpu.h or os and os configuration.h files, os underscore cpu.h, os underscore configuration.h. So this will contains the details of the registers, stack, and all the functions related to the processor. Okay, so os cpu.h and os cpu c.c. So cpu.h will contains the data types. That means in case of our C language, we use the data types like int, float, double, etc. But when we are coming to a microprocessor like 8086, we cannot directly use the data types like int and float. So instead of that, we will be using user defined data types like byte or unsigned integer, like that. Okay, so depending upon the processor, this will change. For 8086 will be it will be a it will be like this unsigned integer. For 8051 there will be bit type data types. So according to the change in processor, the values of OS CPU.h also will change, and OS CPU.c will have the processor specific C codes. This might be for the serial communications using that processor, etc. And there might be also some assembly codes for task switching functions, which will be denoted by OS underscore CPU underscore A dot S51, and S51 denotes that it is for 8051 microcontroller. Okay, uh, these are the types which we will see in case of CPU.h files. That means for a typical C language, we have char type, int type, long type, but these might not be available, or these may not be available with the processor which we are using. So we will be creating user defined data types, okay, in order to port the program to our microcontroller. Okay, the next section is processor independent source files. So the processor independent source file consists of the files related to our RTOS. Mainly two files are there, which is related to our RTOS, which is our MicroC OS, and it is named as MUCOS2 header file and MUCOS2 C file. This will be included in our master header file itself. We can see here MUCOS2.h is included here. Okay, so that too will be there. Then there will be files related to the RTOS kernel, which is the OS core.c. Then there will be files related to the timer. It will be OS time.c. Related to task management, it will be OS task.c. Then there are files related to memory partitioning, semaphores, queues, mailbox, etc. And all this will be there. So in summary, we can say that the source files are classified basically into two. One is dependent upon the processor, which consists of details regarding the portability, so that it consists of the OS CPU.c and h files. Then there are processor independent source files, which consist of the main RTOS kernel, the MUCOS2 C and header files, then OS time, OS task, then semaphore related files, mailbox related files, queue related files. Okay, so we can see the structure or basic structure of a RTOS, which consists of both hardware and software. So we have the processor and the timer, which comes under the hardware section, and above that we have the software section. In the software we have both the system software and the application software. So if you are creating a program for controlling the automatic teller machine or the ATM, so we have the main program which will be running on our MicroC OS2, and the MicroC OS2 will have the processor independent code and the application specific code. Okay, so this is the basic structure of a or the hardware software architecture related to MicroC OS2. We have the CPU, we have the application software, and in between them we have the operating system part. Okay, so the first part in this MicroC OS2 is related to system level functions of a MUCOS. System level functions of a MUCOS. So we can classify the system level functions provided by MicroC OS2 as: first one is initiating and starting the operating system, also initiating the system clock ticks to start the OS timer and scheduler functions. The second section is a combination of three things, which includes the handling of interrupt service routines, handling of critical section, handling of preemption. So there comes the disabling and enabling of the interrupts, the locking and unlocking of the scheduler, and finally we have set and get time functions. So these 5 are the system level functions that we are going to look into. Okay, first of all we will be looking into initiating and starting the operating system. So the function provided by MUCOS 2 in order to initiate an operating system is OS init function. We will be declaring the function as void OS init, and we won't be passing any parameters in it. The function is returning no value, so this function is used to initialize our micro C OS2, and this is the first function we have to call while writing a program. So this would be the first line of our program in the main function. So inside the main function, first we have to initialize the operating system. After initializing the operating system, only we can start our OS. Okay, so void OS init means it will be done at the beginning prior to OS start. Okay, so OS init and OS start are the functions used for initiating and starting the OS. Then one more function is there related to this, which is initiating the timer. So that function is OS tick init. So this is a basic example. We can go through a well-defined example in the next slide. Okay, so let us see how this function works. That is how the initializing and starting the operating system is working. So this is an example program. The first line indicates OS ticks per second, and it is assigned the value 100. It defines that the system clock period is 10 milliseconds. Okay, that means for after every 10 milliseconds an interrupt will be generated in this system. Okay, this is our main function, which is given as void main, and the first function which I will call is OS init. So when I call this OS init function, the OS will be initialized, and after that the first line of code is to create a starting task which is of the highest priority. So I will create a create first task, and inside that I will give the parameters of the task. After that I will create all other tasks which are necessary for my concerned experiment. Okay, so all other tasks will be created inside this first task. After that I will create mechanisms for the inter-process communications. The MUCOS provides mechanisms for mailboxes, semaphores and queues. Okay, after that I will call the OS start function, and next I will call a infinite loop. Okay, now from here what happens when the program executes? At first it will call the OS init function, then it will go to our first task. So inside the first task we will create all other tasks. We will create the inter-process communication variables. Okay, and after that we will start the timer ticks by calling the function OS tick init. OS tick init. So this function will execute only once in the first task function. It will initialize our system timer ticks. That means initially we have said that the OS ticks per second is 100. That means the system clock period is 10 milliseconds. So after every 10 milliseconds this function will be called. Okay, and this is very important for our scheduling of this multitasking system. Okay, so after that only, once the timer start ticking, this will return to our main program, where we will call OS start function. Once OS start function is called, then the processor control will never return to the first task. and all the duties of scheduling the remaining tasks will be done by our processor in accordance with the system clock ticks. ഓക്കെ, അപ്പോൾ ഒരു സമ്മറി ആയിട്ട് പറയുന്നത് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മുടെ ഏതൊരു പ്രോഗ്രാം എടുത്തു കഴിഞ്ഞാലും ഫസ്റ്റ് നമുക്ക് സിസ്റ്റം ക്ലോക്ക് പീരീഡ് അസൈൻ ചെയ്യണം. അതിന് വേണ്ടിയിട്ടൊരു വേരിയബിൾ ഉണ്ട്, അതാണ് ഇവിടെ OS ടിക്സ് പെർ സെക്കൻഡ് എന്ന് പറഞ്ഞ് കൊടുത്തിരിക്കുന്നത്. അത് കഴിഞ്ഞിട്ട് നമ്മൾ മെയിൻ ഫംഗ്ഷനിൽ കയറുന്നു. മെയിൻ ഫംഗ്ഷനിലായിരിക്കും നമ്മൾ OS ഇനിഷ്യലൈസ് ചെയ്യാനായിട്ടുള്ള ഫംഗ്ഷനെ വിളിക്കുന്നത്. അത് OS init ആണ്. OS init കൊടുത്തതിന് ശേഷം നെക്സ്റ്റ് നമ്മൾ ഫസ്റ്റ് ടാസ്ക് എന്ന് പറയുന്നൊരു ടാസ്കിനെ ക്രിയേറ്റ് ചെയ്യും. ഈ ഫസ്റ്റ് ടാസ്കിനകത്തായിരിക്കും എൻ്റെ പ്രോഗ്രാമിന് വേണ്ടിയിട്ടുള്ള ബാക്കി എല്ലാ ടാസ്കിൻ്റെയും ഡീറ്റെയിൽസും ഞാൻ ക്രിയേറ്റ് ചെയ്യുന്നതും ആ പ്രോഗ്രാമിന് വേണ്ടിയിട്ടുള്ള ഇൻ്റർ പ്രോസസ് കമ്മ്യൂണിക്കേഷൻ മെക്കാനിസംസ് എല്ലാം ചെയ്യുന്നത് ഈ ഫസ്റ്റ് ടാസ്കിനകത്തായിരിക്കും. അത് കഴിഞ്ഞിട്ട് ഞാൻ എന്ത് ചെയ്യും, ഫസ്റ്റ് ടാസ്കിനകത്ത് തന്നെ എൻ്റെ ടിക്ക് ഇനിഷ്യലൈസ് ചെയ്യും. അതായത് ക്ലോക്ക് റൺ ചെയ്ത് തുടങ്ങാൻ വേണ്ടിയിട്ടുള്ള ഫംഗ്ഷനെ കോൾ ചെയ്യും. അപ്പോൾ ക്ലോക്ക് റൺ ചെയ്ത് തുടങ്ങി കഴിയുമ്പോഴത്തേക്കും നെക്സ്റ്റ് ചെയ്യേണ്ടതെന്ന് പറഞ്ഞാൽ OSനെ സ്റ്റാർട്ട് ചെയ്യുക. OS സ്റ്റാർട്ട് ചെയ്യുമ്പോഴത്തേക്കും എൻ്റെ RTOS പ്രൊവൈഡ് ചെയ്യുന്ന ഫങ്ഷൻസ് എല്ലാം എനിക്ക് കിട്ടും. ഷെഡ്യൂളിങ്ങും കാര്യങ്ങളും എല്ലാം സ്റ്റാർട്ട് ചെയ്യും. ഈ ഷെഡ്യൂളിങ് വർക്ക് ചെയ്യുന്ന എന്തിനെ ബേസ് ചെയ്തിട്ടായിരിക്കും, ഈ പറയുന്ന OS ടിക്സ് പെർ സെക്കൻഡിനെ ബേസ് ചെയ്തിട്ടായിരിക്കും. അതായത് ഓരോ 10 സെക്കൻഡ് കൂടുമ്പോഴും ഈ പറയുന്ന 10 മില്ലി സെക്കൻഡ് കൂടുമ്പോഴും ഈ പറയുന്ന ഒരു ടിക്ക് വരും. അപ്പോൾ എന്ത് പറ്റും, എൻ്റെ പ്രോസസ്സറിൻ്റെ കൺട്രോൾ കേണലിലോട്ട് പോകും. അപ്പോൾ കേണൽ ഷെഡ്യൂൾ ചെയ്യണോ വേണ്ടെന്നുള്ള കാര്യങ്ങൾ നോക്കും. ഷെഡ്യൂൾ ചെയ്യണമെന്നുണ്ടെങ്കിൽ പ്രോസസ്സിനെ ഷെഡ്യൂൾ ചെയ്യും. അപ്പം ഇത്രയുമാണ് ഇനിഷ്യലൈസിങ് ആൻഡ് സ്റ്റാർട്ടിങ് ദ ഓപ്പറേറ്റിംഗ് സിസ്റ്റത്തിൽ പറയാനായിട്ടുള്ളത്. ഓക്കെ, the next part of system level functions is related to interrupt service routines. Okay, so since we are discussing about multitasking environment, there are multiple tasks are also there, and also there are interrupts also will be occurring in our system. So the CPU scheduler will look into the details about scheduling of these tasks. So how these ISRs are handled, or how the critical section is maintained, and how preemption is taking, and for that we have several functions in our MUCOS 2. The functions provided by MUCOS 2 for disabling and enabling interrupts are OS interrupt enter and OS interrupt exit. So we call by the name OS int enter, OS int exit. So whenever an interrupt service routine is occurring, whenever an interrupt occurs, okay, then what happens, the current running instruction will stop executing and the control of the program will be transferred to the interrupt, so that the ISR will start executing. So in case of our OS, there may be nested interrupts. Nested interrupt means when we are running one interrupt, again another interrupt will be coming, and again one more interrupt will be coming. So inside one interrupt, the next interrupt will be coming. So after every interrupt is finished executing, we have to return to our previous point. Okay, so for that we have a global variable inside the MicroC OS 2. So the system or the operating system will look into that global variable for establishing a well-defined operations of these interrupts. So whenever an interrupt occurs and an ISR starts to execute, the function OS int enter will be called, and inside the OS int enter a global variable which is related to maintaining the safe operations of the interrupts. This global variable will be incremented whenever we enter an interrupt service routine. So once we exit this ISR, that means after the ISR is processed, when we are going to exit, then it will automatically decrement that global variable and exit from it. So we can say that these two functions are twin functions. That means whenever an interrupt occurs, this OS int enter will occur, and whenever we exit from that ISR, this OS int exit should be processed. Okay, these two are the functions which are used for disabling and enabling the interrupts in case of this MicroC OS 2. Both of these functions returns no parameters. Okay, next we have two macros to disable and enable the interrupts. So macro, we know that in C language we have studied about macros and functions. Macros are simple small lines of codes which is used to which may be used to define some variable. Okay, so in case of MUCOS 2 we have two macros, namely OS enter critical and OS exit critical, and both of these are used for enabling and disabling interrupts. So whenever we are entering a critical section, it is required that the processor should not change its control when we are running in this critical section. അതായത് നമ്മളൊരു ക്രിട്ടിക്കൽ സെക്ഷനിൽ ഇരിക്കുന്ന സമയത്ത് ആ ക്രിട്ടിക്കൽ സെക്ഷൻ കംപ്ലീറ്റ് ആവാതെ പ്രോസസ്സർ അവിടുന്ന് മാറാനായിട്ട് പാടില്ല, പ്രോസസ്സറിൻ്റെ കൺട്രോൾ അവിടുന്ന് മാറാനായിട്ട് പാടില്ല, ക്രിട്ടിക്കൽ സെക്ഷൻ കംപ്ലീറ്റ് ആയിരിക്കണം. സോ ഇൻ ഓർഡർ ടു യൂസ് ദാറ്റ് we have two macros, namely OS enter critical and OS exit critical, and OS enter critical may be used whenever we are going to enter the critical section. It will be like setting the interrupt and clearing the interrupt. So whenever we enter an critical section, we have to disable all the interrupts. So the OS kernel will use this OS enter critical command, and whenever we exit from the critical section we have to enable all the interrupts. So there we will be using the OS exit critical command. Okay, these four things are related to interrupts, and the next thing is related to our scheduler. So the scheduler will be scheduling the task according to its priority. That means always the highest priority task will be running. So we also have the option to lock the scheduler so that some of the tasks may not be preempted and will be allowed to run always. So there may be some task in our program which would be having lower priority, but we need to run that task without preemption. So for such task we will be using two commands, which are OS schedule lock and OS schedule unlock. അതായത് നമ്മൾ പ്രീഎംപ്റ്റീവ് ഷെഡ്യൂളിംഗ് ഉള്ള ഒരു OS ആണ് നമ്മുടെ MUCOS 2 എന്ന് പറയുന്നത്. എന്നാലും നമ്മുടെ പ്രോഗ്രാമിൽ ചിലപ്പോൾ ചില കേസുകളിൽ ഒരു ലോ പ്രയോറിറ്റി ടാസ്ക് പ്രീഎംഷൻ കൂടാതെ എക്സിക്യൂട്ട് ചെയ്യേണ്ടി വരും. അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ ആ പറയുന്ന ടാസ്കുകൾക്ക് വേണ്ടിയിട്ട് നമ്മൾ രണ്ട് കമാൻഡ്സ് ആണ് കൊടുത്തിരിക്കുന്നത്, രണ്ട് ഫങ്ഷൻസ് ആണുള്ളത്, OS ഷെഡ്യൂൾ ലോക്കും OS ഷെഡ്യൂൾ അൺലോക്കും. അപ്പം ഞാൻ ചെയ്യാൻ പോകുന്ന കാര്യം പ്രീഎംപ്റ്റ് ചെയ്യാതിരിക്കണമെന്നുണ്ടെങ്കിൽ ഞാൻ എന്ത് ചെയ്യണം, ഈ OS ഷെഡ്യൂൾ ലോക്കിനെ വിളിക്കണം. അപ്പോൾ ആ ഒരു ഫംഗ്ഷൻ വിളിച്ചു കഴിഞ്ഞാൽ പ്രീഎംഷൻ കൂടാതെ തന്നെ എൻ്റെ ടാസ്ക് എക്സിക്യൂട്ട് ചെയ്യും. വൺസ് ടാസ്ക് കംപ്ലീറ്റ് ചെയ്യുമ്പോഴത്തേക്ക് ഞാൻ OS ഷെഡ്യൂൾ അൺലോക്കിനെയും കൂടി വിളിക്കണം. ഓക്കെ, ഇനി ഫൈനൽ സെറ്റ് ഓഫ് സിസ്റ്റം ലെവൽ ഫംഗ്ഷൻ എന്ന് പറയുന്നത് ടൈം റിലേറ്റഡ്, OSൻ്റെ ടൈം റിലേറ്റഡ് ഫങ്ഷൻസ് ആണ്. These two functions are used to get the time and set the time of our system. This will be in terms of our system clock ticks. അപ്പോൾ രണ്ട് ഫങ്ഷൻസ് ആണുള്ളത്. ഫസ്റ്റ് വൺ ഈസ് void OS time set. This is for setting the time of the system. For that we will be passing an variable which is of unsigned integer type. So if you are giving void OS time set count equal to 0, then it is suggested that, or it will set our present count value to 0. Okay, the next function is OS time get. This is used for getting the present time according to our system time. Okay, these are the things we have to say about system level functions. So when we are talking about system level functions, the important things are, first one is initialization and starting of the OS and starting of system clock timer. For that we use the functions like OS init, OS start, then OS timer init. Then we are using for disabling and enabling the interrupts. For that we are using two functions, two macros. Then for avoiding the preemption we are using two functions, namely OS schedule lock and OS schedule unlock. Then for setting time and getting time we have two more functions. So these are all about system level functions provided by MUCOS 2. In the next video we will discuss about the task service functions provided by MUCOS 2. Okay, thank you.